we're going to have a very quick look at a completion transition. We're only looking at what it is. This is not a recommendation to use them. In general, completion transitions are to be avoided. So what is a completion transition? If we look at UML 2.5.1, it says it is a special kind of transition which has an implicit trigger. The event that enables this trigger is called a completion event, and it signifies that all behaviors associated with the source state of the completion transition have completed execution. In case of simple states, a completion event is generated when the associated entry and do activity behaviors have completed executing. That is the case we are going to look at. Note, however, also down here that it says completion events have dispatching priority. That is, they are dispatched ahead of any pending event occurrences in the event pool. Now, the actual result you get there depends on the implementation simulation engine that you have. We're looking at Cameo Simulation Toolkit. Okay, so let's look at, firstly, our state machine to see what the completion transition is. That's our initial pseudo state. We correctly go to a state ready, and then, only then, do we have a transition with a signal trigger, start. And this is the state we'll be looking at. It has an entry activity and a do activity. The entry activity will execute first, and then the do activity will execute. There are two paths out of here. There is one with an explicit signal trigger, and there is one with no explicit signal trigger, event trigger, or guard. That is the completion transition. That transition will be taken automatically when entry and do complete. And we also have here stop going from these two states. Now, the reason this guy is here is so we can see whether or not we are able to interrupt the do activity, as we should be able to, and what happens with the queuing of the events. There is, in fact, a small bug that if you fire this during an entry activity that has a timer loop, it causes a crash. So we have to be careful about when to do it. All right, let's look over here at the setup from the point of view of a class diagram. There's our class test completion transition. It has this state machine here. There is an entry activity and a do activity. These are in fact wrapped by these guys here. The reason is there is a rule that a do activity or entry behavior must be owned by the state they apply to. In this case, there is our state pass-through, and so it has these little wrapper behaviors so that it can own those. They just then delegate to these, all those. There's our signals, and we have a counter. Right, so let's look at the activities. When we enter, it just comes into a timer. After 2 seconds, it increments the timer, prints prefix with entry so we know we're inside this activity, the counter, and we'll keep going around here until the counter is greater than 2. If we look at the do activity, it's almost identical, except it prints the do prefix and it checks whether the counter is greater than 4, because by the time it reaches here, the counter should already be at least 3. All right, I'll see if I can leave one of these open. The window switching is on, which is not always ideal. See if we can run it and see both at once. Okay, so run with context. I've got the animation speed down quite slow here, so we can see what's going on. We fire start, and we are already into the entry activity. So if I visualize that, we can see the counter is incremented. It is printed entry 1. It will go around again. After 2 seconds, it will increment the counter. It will print 2. And now it will print entry 3 and move out of that activity. It now moves into the do activity. Now, while this is running through, I'll just point out that if you fire another event recognized by a transition out of this state, it will interrupt this do activity. But we haven't done that. We've let it run through, and it has taken the completion transition automatically. So all we need to do there is then stop. All right, let's look quickly at the other case. So what we're going to do is we're going to come in here, let it run through the entry. Note that if you fire valid while it's an entry, there is a bug. So we're not going to do that. We're going to wait for it to get to the do activity, fire the signal, and we'll take that transition just to compare. So I've got it around the other side, that doesn't matter. We're ready. Start. We are into the entry activity. We'll allow it to complete. I'll speed it up a little bit. 2 seconds will stay the same, but the rest of it will go faster. Okay, we're now in the do activity. So if I fire valid while we're in there, watch what happens. Didn't fire. There it goes. Must have mishit. All right, it has come out this side. That's the difference. That's the explicit transition. And then we can end. Okay, to summarize, a completion transition is essentially an automatic transition that will always be taken when no explicit event type trigger guard are specified. The implication is that the state that is the source of the transition is not acting like a state in a purist state machine would, because it never stays in the state. Once the entry and do activities are completed, it will always transition. And some would argue that is not a good idea in general for a state machine. Therefore, completion transitions are not recommended here. It's best to have explicit transitions.